so far we know that there is Cisco Discovery Protocol, CDP. We have Dynamic Trunking Protocol, DTP. And we have the VLAN Trunking Protocol, VTP. And now there is another one coming, which is STP. Okay? That's chapter 5. And STP stands for Spanning Tree Protocol. So Spanning Tree Protocol is used to prevent loops and switches connected for redundancy. Fault tolerance. Which means that if I did like this one, or like this configuration that I gave you last time. Now this is a redundant, this is basically I connected a trunk between this switch and this switch, this one and this one, this one and this one right here. So you have in this case what you have is a layer 2. Layer 2 loop, which means that frames can be circling these trunks indefinitely, because on a layer 2 there is no mechanism for decrementing like TTL, time to live, on a layer 3 packet. In a layer 2 packet there is no such mechanism, so the thing is going to keep going and circulate forever and ever and ever, and nothing is going to happen. So what we want to do is we want to make sure that, that if a frame is originated from here, it cannot just go to this switch and go back into that switch. We want to make sure that always there is only one path for the frames to travel. So if I want to go from here, then I can go from here to this switch to this switch, from switch 1 to switch 2, and then from switch 2 to switch 3. But somehow I should block it so that it cannot go back to switch what? It cannot go back to switch 1, the frame. A frame is like, for example, a very good example for frames like that is a broadcast, okay? You send a broadcast to here, this sends a broadcast to here, this sends a broadcast to here, this sends a broadcast, and this broadcasts keep going back in, in continuous loops. So I want to make sure that even though these are connected you see that they are connected like this for redundancy issue, correct? So for example, this switch can send the data this way, but if somebody disconnects this cable, then the data can go which way? That way to this switch. So there's 2 ways to go to that switch. Let's say, for example, for some reason, this cable got disconnected. Can this switch talk to this one? Yes, it can. It goes this way and then it goes that way. Okay? So that's why we have this redundancy. Now, if this cable disconnected, can this switch talk to this one? Yes, it can. It's going to go to switch 3 and then go to switch 2. So what happens is that you have, by doing something like this, we have redundancy. But with redundancy comes other problems. The problems is that some frames might get stuck in an endless loop between these three switches. So somehow, even though they are all connected together like this, I gotta logically, because I cannot just physically come and cut the wire, then there's no point of doing redundancy if I'm gonna cut the wire, okay? So what I'm gonna do is I'm gonna logically somehow block traffic. So let's say for this example, what I'm gonna do is I'm gonna choose to block the traffic here and here. So what I did right now is I'm gonna block the traffic so that the traffic that comes out of this switch has only one way to go out, which is which one? This way. So it goes out this way, and then from here it has potential to go where? This way. But it cannot go out this way to switch 1 because I blocked the traffic. So the traffic is blocked. Now this block is logical block, which means it's done by what? By software. It's not done physically by disconnecting the cable. So for some reason, if this cable get disconnected, somebody physically go and disconnect or shut down the interface or do something, then what happened is that these ports in here are going to transition from blocking into just forward. So they start forwarding traffic again. So then the data instead will start traveling this way and go to this switch. And as soon as I put the cable back in here, then these two ports will go back again to be what? Blocking. When I did this, I broke, when these two are in blocking mode, all what I did is I stopped, so actually, not both of them, just one of them in blocking. That one here. That's all I need. So because the data cannot go because this is blocked. So the data go this way or that way and cannot go out this way, okay? So what happens is that the next, what I do is when I interrupted this loop by putting one of the ports into what we call it a blocking mode, and then this way I only created one path for the data to travel, but the redundancy is still available because when I disconnect one of these cables, then this automatically will unblock itself and start forwarding, and data start going back again this way. So that's what the spanning tree protocol does. The job of the spanning tree protocol is to make some of these ports in blocking mode so that it does not, it breaks the loop in the switches. Now you've seen it all the time, you just probably never paid attention to it. Because now when you connected these together like this, you've seen that some of these ports were in color amber, which means that they were blocking. Okay, the data cannot go through it. Okay, you're always going to see that happens when you connect. There is a loop here. This is the loop right here, because I connected two cables together between two switches. I take two switches. Just try this. Take two switches, connect two cables and two trunks like this. Make two trunks. Okay? If you do this, I just created a loop in here. Data can loop infinitely, indefinitely between those two ports. So what you're going to see is one of the ports in here is going to go amber, which means that it is in blocking mode. It's going to block the traffic. All right. When this happens, then I only, so basically then what happens is what? I'm only using one of these trunks to do what? To forward the data. So even though I put two of them, I'm only using one. Physically there's two, but I'm only using one. The other one is really, no data can go through it because